Welcome to the CRC Roundtable. I generally give people a minute to check in, but we've got a lot to get through and there's a lot of people signing on, so I'm just going to go ahead and start right away. Again, our intention is to host targeted, inclusive, and informed conversations that match scientific advancements and management needs. If this is your first time, these webinars are designed for contribution, not consumption. And as a reflection of that intent, the panelists have been given collectively about 25 minutes to make some introductory remarks, allowing 30 minutes for discussion. So this format is all about us, giving us a place to ask the clumsy questions and to practice the bravery and humility necessary for building the future that we want. I always start by understanding why this topic at this time by these speakers, or really why have 362 people registered for this roundtable. I'm going to first define our terms a little bit. We define stream restoration as an intervention to move a degraded ecosystem to a trajectory of recovery as informed by a reference condition, considering local and global environmental change. So motivation for restoring streams often extends beyond load reductions to improve the status of aquatic biota and riparian corridor habitat, as well as geomorphic stabilization to protect infrastructure. To meet this motivation, the practice of restoring streams has evolved within my own adult lifetime at a dizzying rate. And while studies have demonstrated to some extent the effectiveness of restoration projects in reducing nutrient and sediment loads, the effects on other local stream ecosystem attributes is less certain. Why now? Since 2010, jurisdictions throughout the watershed have implemented approximately 266 miles of stream restoration with an additional 84 miles planned. This rapid increase in stream restoration implementation throughout the watershed has led to a growing concern and controversy about the effects of stream restoration on whole ecosystem health and services. And at this point in the evolution of both techniques, and with multiple objectives, one quote from an economist sums it up for me, and it's actually from one of our speakers' presentations. It's by an economist, Thomas Sowell, who said, "There are no solutions, only trade-offs. You try to get the best trade-off you can get. That's all you can hope for." Our speakers today are going to present a clear-eyed view of the trade-offs and challenges, and they are each some of the most clear-eyed scientists or practitioners that I know of. Greg Noe is for me, the ultimate embodiment of the catchphrase of USGS, which is science for a changing world. He applies that to wetland ecosystem ecology and watershed processes. Many of his reports and papers contain the phrase leveraging existing data for, which indicates the marriage of scientific expertise and pragmatism. So thanks, Greg, for that. And Eric Mikkelsen has a long history of actually doing the walk of restoration in a number of contexts, now currently for Anne Arundel County. I'm happy for that, being a resident. He combines the support of robust restoration projects with rigorous monitoring and bolstered by diverse stakeholder partnerships. And so he does the hard work of working with people. And I usually say, I'm an ecologist because humans are not my best animal, right? So I appreciate what Eric does. The ground rules for the attendees, well, I don't know if they're there, but will be placed in the chat box. Again, I will facilitate the discussion out of the chat and from previously submitted questions. Each of our panelists have extensive experience and they could each fill more than an hour by themselves, but we've asked them to limit their remarks to a short time period, and I'll try and graciously remind them when they're getting close to that. And so with that, I'm going to turn the floor over to our first panelist, Greg Noe.
Thank you, Denise, for that kind introduction. Let me try to share my screen. All right, so welcome everybody. This is a fantastic showing and I'm very excited to be able to be here today. And My job primarily is to describe the results and outcome and what we talked about at a recent workshop that was held by the Chesapeake Bay Program STAC, or Science and Technical Advisory Committee. We held a workshop on stream restoration last year in March. We had have a fabulous steering committee of really knowledgeable, engaged, and contributing scientists, practitioners, and managers, as well as a lot of key support from CRC people here today. And this report, I need to start off by saying, is very much a draft report. We are very close to being done. Our goal is to have this published in March next month. We have a couple of processes to get through before it's done, but we're very close. Everything I say today is reflective of the contributions of all the participants and the steering committee at the workshop, but any mistakes I make are purely mine. So as Denise mentioned, stream restoration is happening a lot, and that's really the reason we're here today. It's a common management technique for addressing total maximum daily loads, or TMDLs, MS4 stormwater permits, stream mitigation purposes, protecting infrastructure, and sometimes habitat improvement too. Typically, success most often has been evaluated in terms of, are we getting the hydraulics of the stream correct and the geomorphology right? And based upon the idea of the stream pyramid, where if we build that base of the physics and sediment, then the biota will come back. As Denise mentioned, in the Chesapeake Bay watershed, this is now one of our most common best management practices, or BMPs, that are being implemented to meet the Chesapeake Bay TMDL. Now, as I'll talk about, that's not the only reason stream restoration happens, but it's widespread. And I would argue that because of where these typically occur, urban, suburban environments, as well as other parts of the Chesapeake landscape, but this is maybe one of the most visible BMPs being done in the Chesapeake watershed for Chesapeake Bay restoration that people actually see and experience close up. So the purpose of our workshop was to bring together a diverse group of experts and stakeholders on stream restoration. And I think we succeeded. We had a lot of different viewpoints, and we had the practitioners, the regulators, the managers, the scientists, the researchers, the implementers, and the communicators in the room. And our goal was to distill lessons learned from past projects to improve restoration outcomes going forward. So to do this, we broke up the topic into 3 sections: the past, the present, and the future. Looking at what has been done in the past, what's the evolution of the goals, regulations, practices, and implementation of stream restoration over time, what's happened in the more recent present time focus, and then fundamentally, the whole workshop was designed to create a synthesis of the best available information on the science and the practice of stream restoration, with the goal of enabling adaptive management, right? The diagram here on the right is actually the Chesapeake Bay Program's implementation of adaptive management. And in order to do better, right, we need to actually assess how well we've done and use that to learn, to grow, and to implement that new knowledge and learning into changing how we do things going forward. In the workshop, we identified what we call the causal chain, and for a very intentional stream pun, I also call this the causal cascade. Kind of explains in a thumbnail framework, we think, for why we're getting what we're getting from stream restorations. So first, streams have been degraded across the Chesapeake Bay watershed. That in turn has led to regulation and policy that requires action to improve our streams. Those then determine the goals of individual stream restoration projects. Those goals then inform and determine the design approach that's used for restoring the stream, what practices are being done. That then influences if and what kind of monitoring of the outcomes are done for that project. And that then determines what outcomes are found. So starting at the top there, but we know that streams have been degraded over much of the Chesapeake Bay watershed historically for a long time. And currently, a lot of the streams, for example, shown in the yellow color here from Kelly Maloney's map and prediction of stream health, indicate poor conditions across the watershed. So a lot of the landscape's degraded. That has some very historic reasons, from lots of legacy sediment from post-European colonization, thick layers of fine sediment draped over our stream valleys, and modification of our streams for other purposes other than natural ecology. And so any individual stream reach, there's a complex cocktail of stressors that are negatively impacting the health of our stream ecosystems. There's a large number. A recent review led by Rosemary Finelli identified several of them. But the key point is that in any individual stream that's a target of restoration, there can be lots of different individual stressors. So what's been the evolution of the goals and drivers and practices of restoration in the Chesapeake? First, we have regulations. Some of the key ones are the 1972 Clean Water Act. Before that point, often the goals of stream restoration, and this is a general summary, there are always exceptions, but typically the goals were for stability of the stream channel for human infrastructure. This is the era of using streams as pipes to get water off the landscape to better human development and land use. After the Clean Water Act, water quality goals became a more common reason for doing stream restoration. In the mid-90s, changes to mitigation rules resulted in a beginning of interest in ecological uplift. But then the 2010 Chesapeake Bay Agreement really pushed the goals for restoration towards the Chesapeake Bay TMDL, total maximum daily load, reducing the amount of nitrogen, phosphorus, and sediment being exported from local streams and getting down to the Chesapeake Bay. Whoa, sorry about that. Okay. So over time, restoration approaches have changed from hydraulic restoration to channel evolution to channel stabilization to natural channel design, and more recently to softer structures and floodplain reconnection efforts. And for the purpose of the workshop, we really focused on after the 2010 Chesapeake Bay Agreement as a more recent marker in time for us to evaluate the outcomes of stream restoration projects in this modern era. So to do that, we created summaries looking at 4 different aspects of stream ecosystem health response to stream restoration: in-channel biotic response, out-of-channel riparian response, geomorphic stabilization of the channel form, and water quality responses. And so we put experts together and they created syntheses of existing literature and findings of stream restorations in the Chesapeake, and more broadly that could inform the Chesapeake. So first, the in-channel biotic group, a key finding is that biotic uplift often is rare. It can happen, it does happen, but most often we're not getting strong signals of improvements of stream benthic macroinvertebrates or fish communities. But we do have some successful examples, and those examples of biotic uplift include single stressor removal projects where one thing is impacting the stream and that thing can be removed. Where riparian health has been improved, in-stream benthic macroinvertebrates have improved in response. Removing fish blockages can improve fish communities, as well as there's been successes in restoring the hypereic biotic communities, hypereic being the area under the stream in sediments. For geomorphic stabilization, we've gotten pretty good at this, actually very good. And particularly with natural channel design as a restoration approach, we've achieved generally stabilization of channel form. Now, again, there are always exceptions. There are some blowouts of stream restoration where they didn't build it correctly. But typically the monitoring has not been long-term. But over the typical regulated monitoring periods of like up to 5 years, overall, we've achieved pretty good success. But there's all little information on some of these newer, softer designs and whether that geomorphic configuration can withstand our larger storms. For water quality, the results are good, but mixed. There are measurable improvements for many projects, most projects, that make stream restoration a viable best management practice for improving water quality, both within the reach being restored, but particularly for downstream ecosystems. But trade-offs and unintended consequences can occur. in the riparian zone. A lot of reason I think why there's a controversy over stream restoration is the mature trees sometimes are cut down in order to restore our stream channels. We found there's often a short-term negative impact on riparian vegetation. There's a loss of existing trees in the riparian zone when implementation occurs. Over time, though, the practitioners and the managers have gotten better at minimizing tree loss. And in particular with deliberate riparian restoration. In other words, not just assuming it'll happen on its own, but actually managing for it, whether that's better planting techniques or removing invasive species, can improve the health of the riparian system. Also, there's been positive responsive of amphibians and soil health in the riparian zone. So ultimately, one reason that biotic uplift may be not as happening as often as we want is because watershed conditioning, including past disturbances, determines the uplift potential of a stream restoration. And that degree of potential uplift could help us set expectations for future stream restoration success. So this is a diagram from Paul et al. 2008 that shows, in this case, along an urban gradient, but it really could represent any watershed disturbance gradient, the range of possible values conceptually of stream biotic health. In a relatively undisturbed landscape, you have a wide range, but a higher maximum. As you get more disturbance, your maximum goes down. So fundamentally, if you have two places you could restore a stream, one low disturbed, one more moderately disturbed, and implement restorations in both, right, there are limits to how much improvement you can get. With less improvement in a more heavily degraded landscape or watershed. And we know a lot of our watershed is pretty heavily degraded. But what can we do differently to get better outcomes? What have we learned? Specifically for biotic uplift in the stream channel, examples of higher likelihoods of success include whether it's that single known stressor, whether that's acid mine drainage or road salts or fine sediment clogging the stream bed or lack of physical habitat. If you can address that stressor and manage for it to reduce its impact, you often get biotic uplift. Biotic uplift more often occurs in smaller streams. And when you can restore the whole stream corridor, including the riparian zone and the floodplain, you're more likely to get success. And fundamentally, with the intentional goal for biotic uplift, if that's really the goal and you make it the goal and act accordingly, you're more likely to get ecological uplift. So some sweet spots in the landscape.
You have about 2 minutes.
Okay, Denise, we're close. Some sweet spots in the landscape to target restoration for a greater likelihood of biotic uplift. Target head cuts and nick points, concrete channels, buried streams, headwater streams, areas, in other words, that are fairly messed up already, but particularly if they're in a landscape of a less degraded watershed, they have more uplift potential for these degraded locations. Remove fish blockages and reconnect floodplain stream ecosystems, and give it time for these streams to react and improve. It may not be instantaneous. So some key findings. The fundamental finding of the workshop was that typically the primary goal for stream restoration has been not to improve ecological uplift. Typically, these projects are TMDL projects to reduce downstream nitrogen phosphorus sediment loads. And therefore, these projects have often not improved aquatic macroinvertebrate and fish communities. There are several others on here. In the interest of time, I'm going to skip forward a little bit, but we have a lot of recommendations coming out of the workshop, and maybe in the questions we can go over some of these too. But to summarize and to conclude, if ecological functions or ecological uplift or biotic uplift is really our main goal as society, as watershed or stream managers, then we need to explicitly identify them as the goals for stream restoration projects. Make them your goal, incentivize that goal, and act accordingly. Use appropriate restoration design approaches to achieve that goal of biotic uplift, and monitor these restoration outcomes. There's still not enough monitoring data to really assess the practice of stream restoration. And a key scientific gap is we need better science to understand and predict which stressors are actually impacting an individual stream reach for example, one that we're targeting for restoration. So we can choose the best or most appropriate management technique to target those stressors. So with that, I'm going to wrap up and end, and look forward to Eric's talk and having conversations with you all in a little bit. Thank you.
Thanks, Greg and Eric. The floor is yours.
Great. Thank you. Okay, can everybody see my screen?
We can, and I
Okay.
think if you go to slide, there you go.
Excellent. Thanks so much, and appreciate the opportunity from Denise and CRC to be part of the presentation, and certainly appreciate Greg's comments. A lot of what I'll talk about builds on the findings of the STAC workshop and some of the things that Greg spoke about. As Greg touched on, you know, again, the sort of near-term driver for the vast expansion and acceleration of restoration of all sorts that we're seeing in the Chesapeake region is, of course, the Chesapeake Bay TMDL from 2010, and then subsequently in many of the urban jurisdictions, the so-called MS4 permits, the stormwater permits that are associated with basically going back into the developed landscape throughout Maryland and Virginia and DC and elsewhere in the Bay watershed, and correcting the sins of the past, trying to address stormwater issues that have existed for decades, and to begin to chip away at some of the nutrient and sediment impacts associated with that work. And so that's really the, as Greg had mentioned, the near-term driver in terms of this activity. But sometimes I think that the extent to which that is looked at as singularly being the focus is a little bit overstated, although it's certainly why the money for restoration is around, those regulatory obligations on the states and local governments. I've been in this space for about 20 years, but just looking at the past 10 years, it's really remarkable. And I think Denise sort of alluded to this in her opening comments, at how much evolution, how much change there has been in this space, and how much really thoughtfulness and sort of adaptation based on the best available science has occurred. So in 15, 20 years ago, even 10 years ago, frankly, the lion's share of what was being purported as stream restoration was really what these images of what we see on the left, essentially stabilization of these single thread systems through stream valleys in order to make sure that we weren't having bank erosion, that the system was not accumulating sediment so that it wouldn't experience structural failure. And that was sort of the state of the art at that time. In the last decade or so, and really, I'd say more dramatically in the last 5 years or so, there's been a broader recognition and adoption of the notion that perhaps we were thinking about these systems a little bit simplistically in terms of what we're aiming to restore to. And a lot of us, and I'll talk a bit about more about this in my presentation, are really focused more on the development of what I'd call these retention reaches at this point, which is systems that are designed to not just arrest sediment, but to actually accumulate sediment, to accumulate carbon and water in the basic building blocks of these aquatic systems based on the science as it exists now. And one of the things that I'll mention as well is that a number of us, and really I think Maryland has been a leader in this space, working with the Chesapeake Bay Trust, recognizing that the science in this space was inadequate 10 years ago, really worked together to bring together a pooled monitoring program with the trust, where local governments, state governments, other stakeholders basically aggregate financial resources so that rigorous research can be done to answer some of the pressing questions from the regulatory community and from the practitioner community in this space. As I said, and again, Greg alluded to this a little bit in his presentation, this is the stream functions pyramid developed a little over a decade ago, really sort of the critical paradigm, I guess, maybe for thinking about how restoration works and sort of how these kinds of traits stack on top of each other. As recently as a decade ago, there was a widespread belief or thought in the restoration community that really in terms of restoration, the only things that we were capable of controlling, or sort of the most basic things we were capable of controlling, were these elements 2 and 3, the hydraulics and geomorphology. And so one of the questions before the roundtable that was asked was about form-based versus process-based restoration. And so a lot of the restoration, those development of those transport reaches, was a form-based restoration. Essentially, this is what we think healthy streams look like. This is how they have to function in order not to fall apart. That's what we're aiming for. And a number of us, in fact, thought, well, you know, that hydrology tier at the bottom actually is the most important. And if you don't get that right, probably you're not likely to see success on those higher tiers. And I want to talk a little bit more about that, but I think it's fundamental to understanding sort of where some of us are in this space, and also the nature of the fact that there are, you know, well-intentioned disagreements among folks who do this work. This is a diagram put together by a firm from Pennsylvania called Land Studies, basically just sort of laying out sort of these two alternative, I guess, visions for these valley systems. And you may notice I'm trying to avoid the word stream altogether, because as Greg had pointed out in his presentation, really this, if we look at these as integrated riparian systems where we've got healthy wetlands nourishing streams and vice versa, that's probably, in my mind, how we're going to get the best outcomes across the board for what we're looking at. So this is that legacy sediment story that Greg talked about, where we had historical agricultural sediments dumped into these valleys over the course of the past several hundred years. And we've come to think of those impaired systems as sort of reference or idealized systems, when in fact what we really are more likely to be looking at is a system that's been pretty heavily impacted. And that if we really want to get back those functions that Greg referenced, we probably need to look at the processes that were going on in systems historically. I'm just going to go real broadly and quickly through a number of slides. And this, I think these slide shows will be available to folks if they want to look at them further down the line, but just hit on some high points here that, you know, we need to be building systems that are hydrologically nourishing, where we're returning water to the system. And a lot of the work that's gone on historically where you're channelizing these systems is in fact working contrary to building hydrology in the systems. If we're building systems that are transport reaches where we want to make sure that they're sort of self-flushing, we're also incidentally blowing out those basic building blocks of biology in terms of carbon and whatnot. In a lot of stream systems, again, historically, we're seeing wood used, but it's being used in the way that we would use stone in terms of armoring. It's not being used to create roughness or interrupt flows. It's being used to prevent erosion, like I say, in a way that stone would be used. And then as we get to that next tier, the physicochemical tier, this issue of these riparian wetlands in connection to floodplains is critical in terms of nutrient reductions that we would see in those areas, and disconnecting from those systems or leaving them disconnected, you know, leaves us in a spot where we're not likely to see those kinds of reductions. And again, then biologically, you know, Greg referenced this. We're not seeing the kind of biological uplift in a lot of projects that we'd like to see. And in some respects, that might not be that surprising if we're not leaving the other building blocks for biology into these systems. I want to talk a little bit about some of our own restoration work. A lot of the work is TMDL driven or driven for these regulatory needs. It also co-occurs with infrastructure concerns. This is a Cat Branch project where a sewer line was exposed in the valley. Sort of the historical approach to that would be from a utility group would be coming in, dumping stone, and then expecting that to be gone in 5 or 10 years, and then coming back in and doing it again, because they just don't have the resources or the capacity to do something more holistic in terms of those approaches. So this represents a rare opportunity for us to really work collaboratively with those infrastructure agencies. These are some more pre-restoration shots of that area. Folks have seen these kinds of streams all over the place. And then I've got a series of post-restoration site photos. These are immediately after restoration. You can see the water, the hydrology returned to the system as that ditch was plugged and the valley was restored in terms of hydrology. Immediately after restoration, obviously some tree impacts here in terms of those kinds of near-term issues. But this is within a year after construction, really healthy wetland community coming into that area. A drone photo of the same area, you can see how wet and uniformly these wetland characteristics are across the site. This site, we saw over a 230% increase in wetland square footage in the valley post restoration after delineations. And these are just some additional photos of that site continuing to evolve over time. So there are, as Greg mentioned, oftentimes near-term riparian impacts, but in many cases, those resolve themselves fairly quickly with the right plantings and whatnot. You know, it's key, and I think it's discussed somewhat in the comments, but I think it's a key piece is this community engagement. Obviously, we're doing this work for environmental resources, but communities are oftentimes, you know, lined up with these projects. And so to the extent that they can become community resources and can enhance quality of life, that's an important thing for us, especially in the metropolitan area where we do have a lot of our work going in among homeowners or businesses. And just want to say that in many respects, a lot of what we're doing is reminiscent or, you know, trying to emulate in some ways beaver activity, which is pretty dramatically returning back to the landscape. This is actually a beaver dam on one of our projects in the Severna Park area. And so the next several slides, again, is sort of contrasting that transport reach approach with retention reaches, and beaver systems would be retention reaches as well. But demonstrating that it is possible for us to change hydrology, even at sort of at the reach scale or at the valley scale by, again, plugging those systems and returning water across the landscape, that we can create ways to retain that organic material, which is, again, the fundamental building block for biology in these systems, as well as also reduce peak flows downstream in terms of flooding issues or those kinds of things. And that geomorphologically, we can incorporate wood into these systems in a way that actually interrupts flow, that creates habitat, that creates roughness, that creates some diversity within those systems that provides value. And that we get those physicochemical benefits in terms of nitrogen processing in particular, when we have that retention, when we have that wetland creation. Those features are critical in terms of processing and reducing nitrogen downstream. And then again, biologically, and it's not that much of a surprise, I think, that if we don't have systems that are just rife with water and carbon, we're probably not likely to see the kind of biological response that we want to see. But when we've got abundant water, when we've got the building blocks for the feed stock for fish and whatnot, that those tend to be systems that are better for particularly young fish, where these areas can act as refugia in some cases. So I just want to finish by, you know, really hammering this point that hydrology, in my mind, is a critical feature of what we're aiming for, and that really the rest of these elements that we're looking for build upon getting the hydrology right, and not building systems that are prettied up pipes, sort of as Greg had referred to some of the early restoration efforts, but that are really fundamentally changing these positions in the landscape in a way that makes them much more functional from an environmental standpoint, but also from a habitat and community benefit perspective. So thank you for the opportunity to present. I look forward to the questions in the Q&A.
Oh, thank you, Eric. And thanks again to Greg. Just to remind people, we had almost 100 questions submitted beforehand, but we'll also answer them out of the chat, and I'll do my best to go back and forth. So please feel free to enter your question in the chat. And just to remind you that if we don't get to your question either in the chat or what was submitted ahead of time, we do make an effort to follow up with our panelists, have them answer those questions, and then send out the results to all of you that registered. So with that, let me start out, and I've got a lot of questions, as I'm sure everybody else does. One of them is Greg, you alluded to biotic uplift is rare. And because both of you have seen a lot of projects and looked at a lot of studies, could you give me a general characterization of the body of evidence to support claims of biotic uplift, both in its robustness and the level of uncertainty that's
Sure.
engaged in that, and both kind of short term and long term. So, Greg, if you want to take the first crack at that, and then Eric.
Sure. So first of all, the um, general rarity of biotic uplift refers to in channel. First of all, in the channel, aquatic benthic macroinvertebrates and fish. Outside the channel, there's often biotic uplift.
Hmm.
So that's one caveat, right? Is it, and one of the key recommendations, which I didn't get into, was we need more holistic measurement of stream health outcomes, but beyond stream macroinvertebrates and fish because of this. But oftentimes in the past, natural channel design kind of stream restoration projects that were intended to stabilize, and many of these practitioners and implementers may have a secondary, and often do have a secondary goal of improving habitat, but it's not the primary driver of the project. There have been several good studies of multiple restoration projects. Chesapeake Bay Trust has been involved in many of them, as well as others, a lot of good scientists, and it's sometimes tough to see a strong signal of biotic uplift because of restoration. Generally, but they do exist, and we tried to highlight some of those examples of where it has happened.
Great.
But
Eric? Oh.
One last thing is that, it's a lot of us want biotic uplift, of course, but there can be legitimate goals for stream restoration that do not include biotic uplift.
Yeah, Denise. So what I would say, and I think Greg sort of touched on it, which is that in terms of biotic uplift, I think we've got a fairly narrow view of what that constitutes at this point. I think there's a lot of focus on stream insects, and to a certain extent, increasingly on fish, which I think is a move in the right direction. But I do think a broader understanding of sort of biological response that incorporates, not just insects, fish, amphibians, reptiles, probably even in some cases, the bird life and those kinds of things, maybe small mammals in these situations, tells a broader picture. And I think, it's interesting as we've begun to look more at fish in particular, the story seems to be a little bit less I guess pessimistic maybe than looking at insects. Insects are really tough, and I think there's questions about not only like what are the particular stressors within watersheds that are causing them to be not present in the first place, but also once they're wiped out, what are the mechanisms for them to potentially return? Their dispersal patterns and those kinds of things can make it very difficult, where even if potentially you've created good habitat, is it reasonable to expect them back if there aren't populations within a certain range of your restoration project? And so one of the things, I didn't really hammer it too hard in my presentation, but one of the things, that we've spent a lot of the last decade looking at is getting these water quality questions pinned down. And it feels like the lens is now moving more into this biological space, which I think is right, and I think it makes sense. And we've got some really interesting tools like eDNA and other kinds of things that are coming onto the scene to really help us, I think, begin to explore those questions in a way that hasn't been done before. So I'm looking forward to the next 5 or 10 years of scientific research really being more focused in that direction as some of these water quality questions, fall to the wayside, hopefully.
That brings up a question. I mean, I had a quote about trade-offs in my opening remarks, and I'm wondering if that is appropriate. So if we sort of flip the script and we said, instead of saying, do we get biotic uplift from projects that are done for water quality or geomorphic stabilization reasons? Can we kind of flip it? And is it possible to have it all? Can you do projects that you get biotic uplift, geomorphic stabilization, and water quality improvements?
You know, I think it
Eric,
is
I'll
possible.
ask.
Yeah, I think it is possible to have it all. But you know, Greg really had a nice slide that showed it, which is to say, you know, we want to be very careful about intervening in systems that are already like sort of well functioning, or maybe the watershed is in good shape. It's a fine line there, which is to say, it may be that the best biological response you can expect is in a system that's not that poorly off to begin with. But then we're going to get into questions of, well, does it really make sense to intervene at this level there? And so I think that's a sort of a broader philosophical question. I personally like operating in the space of you know, ostensibly pretty highly degraded urban streams where there may be not a very high expectation for response, but where just at least anecdotally, you can get some pretty biologically active systems in an area that might be kind of surprising to people. But I think that is a question, and it's one where we just want to be careful about, again, the sort of potential trade-offs involved in intervening in those systems that might have a higher ceiling in terms of outcomes.
Greg, anything to add?
Yeah, that's a great point, Eric. And that's kind of where definitely we went in the workshop. And to paraphrase, you know, do no harm. Now, that's one way to avoid trade-offs. Avoid those high quality streams in good landscapes where your intervention is unlikely to improve the biology. But there are lots of places with bad biology that have other problems. And there's lots of places with bad biology that could have better biology through intervention, through stream restoration. So choosing location is critically important to minimize the severity or likelihood of those trade-offs. And you know, another key metric for stream restoration success is public engagement, as Eric emphasized. Getting people into the streams, I think, is a potentially big benefit of stream restoration and getting them aware. And you know, one of the negative trade-offs often is the riparian tree loss. And maybe because I work a lot with geologists, but I often take the longer view. Many of these trade-offs are relatively short-term. And that's not to minimize that the public has values for these streams that are real. And you know, they truly do value these trees sometimes, often. But oftentimes these systems will, to a degree they can, respond to our attempts to approve them, but it can take some time. So some of these trade-offs are short-term, some are long-term, and that's what I think we have to really work to avoid.
We had a lot of questions about, and I almost hate to bring it up because it's a really difficult question, but you know, cost effectiveness, right? And it would depend on the objectives. And I think, Greg, you brought up a point that was really striking to me, which is something that we really don't measure is on the public engagement front. Like, what is the value of that? And it is the BMP that people are most likely to really experience firsthand. So, you know, what do each of you, is there a way to respond to that question in a reasonable way, right? Because it's not necessarily going to be cost effectiveness and a nutrient reduction standpoint. I mean, that's going to be tough. They are costly projects, right? So what's the response when people say, are they worth the investment? You know?
Well, if Greg doesn't mind, I'm happy to jump in, even though I went first last time. You know, I think I make the distinction between costly versus cost effective. So yes, these projects tend to be costly, but that doesn't mean they're not cost effective in terms of these reductions that we're getting. In a lot of cases, this is the position in the landscape where there is this, you know, the sediment and phosphorus pollution is actually being produced. And so you could put practices in above these systems, and you may take a little bit of the pressure off of them. But the reality is that you're probably not going to really be significantly reducing the amount of sediment that's going to be generated through them for the most part, unless you do something massive. And so I think, yes, just because they're expensive, I don't think that should be exclusionary. I think, you know, we have to certainly explain why it's a value, but many of the alternative practices, especially ultra urban practices and those kinds of things, are easily 5, 10, 15 times as expensive on a per unit treated in terms of some of these water quality goals, with some of the same scientific questions in terms of benefits that remain for those practices as well. They just haven't been quite as scrutinized on that front. So I think, I think that's the extent of my response. Greg, I don't know if you have anything to add.
Yeah, cost, as you point out, is many things, but cost is not just the total number of dollars spent on a project. There's other costs that should be considered. So for a lot of the Baltimore DC metro corridor, stream restoration is the go-to BMP for public agencies to implement in response to the Chesapeake Bay TMDL, because it's cost effective in that they often can have access to control the stream valley to manage it. And dollar per pound reduced, it's fairly cost effective. So they're not inexpensive, but right through our economy of choices in the landscape, we're choosing stream restoration as one of the most dominant BMPs out there. So I think it is cost effective. Whether that's the appropriate goal or not, I think is the larger societal question. But part of the cost effectiveness too, I think, is, well, that answer will take a lot of time. I'll put a stop there.
Okay. I think both of you really answered. There's a lot of questions in here about, what are key factors, and I think that varies a lot with context. So I might save that question. We do have a couple questions, and one of them is in the chat, and there was one beforehand. Matthew Drennan wrote, recently we have seen pushback on these types of valley-wide floodplain restoration in regards to the riparian impacts and the insinuation that increasing floodplain retention and slowing the flows actually increases water temperature and negatively impacts fish habitat, especially in native trout habitat. Has there been recent data that support these types of claims? And actually that goes along with a question that got submitted that said, what stream restoration practices would you recommend for balancing TMDL goals with temperature reduction goals?
I'll try first.
You can go first. Yeah.
Yeah. So my caveat is I'm not a fish biologist, but I'll paraphrase what I learned through the STAC workshop and talking to the scientists and practitioners. Okay. And that is, yeah, we probably don't want to do anything to warm up temperature where there's brook trout. So again, do no harm perspective. Where a lot of these projects for floodplain reconnection and valley wetland restoration are being done, though, are not brook trout habitat. There are other fish species sensitive to temperature, and we do have to worry about temperature. So I think, again, careful placement of where we do that kind of approach really matters for what resources you want to try to preserve versus what you want to try to get out of it. And I realized one thing I wanted to say from an earlier question, which I think is relevant too, which is what's the kind of the counterfactual of doing nothing for some of these projects? Will stream health get better? If we do a stream restoration project and there's no improvement in stream biology, however you measure it, is that a bad outcome when it could be getting worse? It's a hypothetical that you have to kind of evaluate the situation, but it's a key consideration, I think.
Yeah, I think Greg makes some good points. This is an interesting one, and I committed to answering Matthew in more elaborate response offline, but I think it's a fascinating one. If you look at sort of the state of, say, anadromous fisheries in Maryland or throughout most of the country, frankly, it's been a pretty steady decline over the course of the last century or more. And so, holding the line or doing sort of what we've always done in terms of fisheries, from my perspective, and I'm not a fisheries biologist, but from my perspective, is probably not the path forward. And a lot of the best work in this regard, in my opinion, is actually coming out of the Pacific Northwest, where you can imagine there's a high priority in terms of salmon recovery and restoration, and that fishery still means a tremendous amount to the folks in that region. And a lot of that work, indicates that these systems, again, sort of, whether it be beaver impounded systems or retention systems, are really critical habitat for those anadromous fish. And I'll I said it at the Stack workshop, I'll say it now, that's kind of anathema in some respects to a lot of contemporary fisheries management. You know, there were times where people were, you know, blowing up beaver dams with dynamite in the Midwest in the names of, you know, brown trout fisheries or whatever. And so it's, I think there needs to be a bit of a paradigm shift there, frankly. And I think that what we've been doing hasn't really been working in that regard in terms of those fisheries recovery. And so I think what Greg says about this counterfactual is actually a critical point. It's like, let's try something a little different, you know, not necessarily in existing high quality brook trout watersheds, but in other places, and let's see what the response is to that. And then maybe that's something that could be more broadly adopted in time if it's successful. But I think you know, restoring the hydrology to these systems is probably one of the best ways to nourish these cold water fisheries and these other kinds of systems that are dependent upon these resources. So.
Thank you. That was a great response, and I really appreciate the counterfactual. That's something I hadn't thought about. There's quite in the chat. There's a lot of interest, and I think you make the point about how I think it's really striking that this is a BMP that a lot of the public, that's something they can see and experience, right? And it speaks to, you've also talked about the need to really manage expectations, right? Not manage them, but make sure you're aligning with expectations and talking about things in that way. Can I ask each of you to kind of opine on what you think the elements or for really effective public outreach about stream restoration is? I mean, is it this really clear presentation of expectations, you know, temporally and how in whatever way? But could you just comment on either, you know, what you've seen through the workshop or Eric, in your experiences about what are important things to keep in mind when you're doing that public outreach?
Yeah, I think a couple of things. I definitely think expectation setting is huge. I think we don't want anyone to go in, you know, when the bulldozers and excavators are out there. I don't think we want anyone to be surprised by that. I think we want to, you know, recognize and explain to people that, look, there's going to be a period of disturbance here, and then there's going to be a period of recovery here, and explain, you know, why it's being done. I mean, you know, the responses vary as widely as the number of people that you're interacting with. Some people will welcome this kind of work going on in their backyards, and others will say, you know, why have you targeted us? You know, essentially as though there's something punitive associated with it. And so I think my approach has been really to over communicate on the front end with these kinds of things, to recognize there are no dumb questions. There are lots of bright people who've got reasonable objections or concerns about these kinds of things, and to try to address those as frankly as can be done, and to recognize that at the end of the day, I think all of us are hoping that these are not just water quality benefit projects, but like I say, they're community enhancement projects. They're creating places where parents and kids can go with their you know, their net down to the stream and catch frogs or fish, or they can walk the nature path alongside the stream and those kinds of things, and really try to be upfront about that sort of thing. So that's my approach. It doesn't always work, but you know, I think it's worked largely so far. So.
Great.
I don't have a whole lot to add, but in my own personal life, seeing engagement that's happened, a lot of the streams that are being restored have really steep, tall banks that are dangerous to get down into the stream. Kids can't do it anymore. Adults can't do it anymore. You know, those cross vein boulder structures are really effective for safely walking down into the stream and experiencing it. That has to pay dividends long term. But one thing about the Stack workshop that we focused on was the terminology stream restoration is too limiting right now. And that oftentimes it's such a large umbrella project. There's a lot of public misconception about what the actual goals are for the project. And through engagement, right, you can communicate that. What are the trade-offs? Why are they doing the project? Were there trees here 50 years ago, 100 years ago? But also, you know, instead of just calling it stream restoration, call it a stream restoration project for whatever your goals are. Stream restoration project for protecting your sewer line, or stream restoration project for improving fish habitat. Be more explicit in the, how we call these restorations is a recommendation we have.
Great. If we had a couple questions on really are the current laws and policies, and I would say funding, design, permit review, construction practices, sufficient to facilitate effective stream restoration? Is there something that's really presenting an obstacle in terms of getting the projects completed for their intended objective?
I would say,
Go ahead, Eric.
I would say that, for the most part, the process in Maryland, I think, works pretty well. That's been the result of a lot of conversations with practitioners, with the Army Corps of Engineers, with MDE, to a certain extent with DNR, and really building sort of a basis of shared experience on it, and projects that, have succeeded in some form or fashion to build that trust relationship. And so I'd say we're in a pretty good place. I mean, as a practitioner, I'd always like to have less hoops to jump through, but I think that we're in a pretty good place in terms of there being a good balance between the regulatory oversight and justification necessary for work going on, and that work being able to move forward in a smooth and not overly onerous way. So I think we're generally in a pretty good spot, I think.
Great.
Quickly, 2 points. One is that it's fundamentally all of this revolves around incentivization. Right now, streams are mostly being restored for the Chesapeake Bay TMDL. If we want more streams to be restored for biotic or ecological uplift, that has to be incentivized somehow. We don't have answers. And of course, I'm with USGS. We have to be very careful not to suggest policy. But if our goals are biotic uplift, something needs to change. The second point that came up often during the STAC workshop and is in the report, draft report, is that currently most permits for stream restoration, I'm told, a condition of the permit is to achieve biotic uplift as a result of the restoration. But apparently sometimes, or perhaps commonly, I'm not entirely sure, that's not enforced. There's no going back afterward and saying, you didn't, what are you going to do? Or so I'm told.
Great. Let me see. I think actually I will use the time, because it's usually not, if I give you a minute each. After sort of getting ready for the roundtable and listening to seeing some of the questions and through the discussion, I'm going to ask each one of you to sort of ask for, what do you want this very large community to walk away with? And I get the impression that it is a robust learning community, that people are really collaborating and cooperating across all kinds of sectors, right? But so what's your parting sort of gift to the learning community that you'd want them to leave with today? And I'll let Greg go first.
Okay. It is, I think, an engaged learning community. And I was amazed at the workshop with how sincerely people wanted to learn to improve. But again, some perspective, this is a relatively new approach, practice, industry. It's not that old. And over the short time where it's really taken off, there has been learning, there has been improvement, there has been changes in response to seeing what has worked and has not worked. So I think sometimes stream restoration is like a black or white thing. Does it work or not? But it depends, of course. And it's not just me because I'm the scientist, but we're doing things differently now than we did 10, 15, 30 years ago. That's good. That's what we want. So it's an evolutionary process. We're learning, and we need to learn more, because this is going to stick around and be an important tool in our toolkit that we need to learn to make it better.
Great. Eric?
Yeah, recently at a public meeting, I sort of got dinged for having said at one point that I saw every project as an experiment, and I stand by that. I still feel that that's true. And I think to a large extent, the practice is always going to lead the science. That's just the nature of this kind of thing. I mean, that practitioners are sort of going to have their own impressions of what's working and what's not working and tweaking, and the scientists are going to follow behind, studying what's gone into the ground to see, what in fact is working well, or how well it's working or not working. And then that's going to inform future practice as well. But I think that, to Greg's point, I think it is a pretty reflective community. I think the feedback from the public is helpful in terms of making us, sharpen our pencils and our approaches in terms of this work. And I also look forward to, I think the future where what the things we're going to be looking at, understanding scientifically, are going to be probably more focused in this biological direction, which I think at the end of the day is what people are really looking to see. So I agree with everything Greg said, and I really appreciate the thoughtful questions from the group.
Yeah. You are the perfect panelist. We are at 1 o'clock. I would thank both the panelists. That was wonderful. And also everyone who attended. Your questions were very, very thoughtful and thought-provoking. I'd say please join us on March 20th. We're going to look at tools to align local government priorities with water quality and the watershed agreement. And those are going to fit right into what we talked about today. So thanks again. Again, you will get a link to the recording and the answers to the questions that we didn't have time for. Thanks very much.
Thank you.